Hey guys, it's Watley here, and tonight we're going to be talking about writing formulas for arithmetic sequences. So before we get into that, I have a little joke for you since it's close to Halloween. My joke is, how do you fix a broken jack-o'-lantern? So stay tuned because at the end of these video notes, I am going to reveal the answer. But for our notes, our objective is students will be able to write a formula for the nth term of an arithmetic sequence and analyze the given terms to determine the sequence's pattern. And our essential question is, how can explicit formulas be used to determine specific terms in a sequence? So make sure that whenever you get finished with your video notes and you're about to write your summary, that you go back to this essential question and you answer this in your summary. Okay, before we get into our lesson, let's review a little bit about the nth term. From a sequence, this sequence we have 7, 9, 11, 13, and 15. So if we look for the pattern, we find that the difference between each term is 2. This value is referred to as the common difference. So let's write in common difference because that's going to be our pattern that we see in between each consecutive term. So when we try to find the nth term, which can be any term that identifies the position that a value has in the sequence. So the formal definition, the nth term of the sequence is the position a value in a sequence holds. So if we look for the fourth term, for example, in the above sequence, we can see that our fourth term is 13, and that can be represented a lot of different ways that you've probably noticed so far. So it could be that your arithmetic sequence A sub 4 is equal to 13, or T sub 4 is equal to 13. We're going to see that a lot in these video notes. You could see A parentheses 4, which means A of 4 is equal to 13. So we're getting into some function notation here. T of 4 is equal to 13, or F of 4 is equal to 13. This all means the same thing. It's expressed in a variety of different ways, but you need to understand that it all means the same thing. In any one of those representations, you can tell that the fourth term is equal to 13. And so then we also talked about finding the nth term from a function. So here we need to go back and think about our function machines, where if you have an input, we input that into our function machine, we should get an output. So if we look here, we have a function A of n is equal to 2n plus 3. So here our input is going to be 7, and we want to input that directly into our function to replace our n value. So this is also known as substitution. So if we substitute that, 2 times 7 plus 3, we're going to get a unique output for that input, and that's going to give us 14 plus 3, and that is equal to 17. So let's put that down for our output whenever we try to find the seventh term. Okay, over here, our function f, we have the same situation. We have to find the second term, though, and now we're going to input that into our function machine for x. So let's go ahead and do that. We're going to have negative, and then in parentheses, I would like to put 2, since that is our input, plus 5. And that's going to be negative 2 plus 5, which is 3. So let's write that down for our output. And that's how you find the nth term whenever you're looking at a function. Okay, so to start off this lesson, we first need to understand what the explicit formula is. So this is part of your vocabulary to write down this formula. So just put it inside our box. It's T sub n equals T sub 1 plus D. Then in parentheses, we have n minus 1. So each of those terms means something different. So we also want to write down what each of those different parts of that formula mean. Starting with T sub 1, which I've written in green up above. This represents our first term of a given sequence. So if we have a sequence, we refer to the first term as T sub 1. Okay, so the other thing that you might notice in this formula is the n, which I have notated in red ink. that's going to represent our nth term. So let's write that down on both lines because that is just going to replicate each other. So nth term on both of those. So if I ask you to find any term, you should be able to just input that into our formula. And then the other thing that we might see here, the other variable is d, which that represents our common difference. So we're going to need to know each part of this formula in order to get a really good equation or an expression that helps us find any given term. So common difference for D. So there is our formula, and let's get ready to do our first example. Okay, so example 1 says that we have a pattern of cubes, and that's shown below in the 4 figures. So when you start to create your table in step 1, let's make our first row our figure numbers. So figure number 1, 2, 3, and 4. And then when we talk about our number of cubes in the second row, we're going to have to count how many cubes we have in each of those figures. So let's do that. Okay, in our first figure, we have 1 cube. In our second figure, we have 3 cubes in figure 2. In figure 3, we have 5 cubes. And in figure 4, we have 7 cubes. What the question is asking us, though, is if that pattern continues, we need to write an expression that can be used to find the total number of cubes in figure N. So to do that, we need to make sure that we have the formula down. So I'm just going to write that down underneath step 2. I'm going to rewrite the formula so we can identify the different parts of the formula that we need to have. So I wrote the formula below, T sub n equals T sub 1 plus D, and then in parentheses, n minus 1. What we need from this formula is our first term. That's going to be identified by the first figure that we have. The number of cubes in that figure was 1. So our T sub 1 is equal to 1. And we also need to know what our difference is, our common difference. And so if we identify our pattern, it looks like we are counting by 2's each time. So each time our figure grows, we have a pattern of increasing by 2 cubes. So our D, or our common difference, is going to be equal to 2. Those are the 2 things that we need for this formula. Okay, so once you have identified the values that you need, which is the first term and the difference, that's what you need in order to create or begin to create your equation. So we've plugged that in over here, and now I need to simplify. And so our simplifying steps are to distribute, which we need to distribute the 2 that's in front of our parentheses. That's going to give us 1 plus 2n minus 2. So step 1 of simplifying is to distribute, and then we need to combine our like terms. So if we look for like terms, we don't have any other n's that we can combine, but we do have the 1 and the negative 2. Those are like terms that we can put together. So then what we have is 1 minus 2 going together, but the 2n, like I said, we don't have anything to put with that. So let's write this as 2n minus 1. And I'm going to bring down the T sub n, and we have our equation. T sub n equals 2n minus 1. Put a box around that, and then in step 3, we're going to check our answer. So to check my answer, I'm just going to pick a figure. I'm going to go with figure 4, and we're going to use this formula to make sure that I get the appropriate number of cubes whenever I look for the 4th figure. So if I want to check figure 4, I'm going to use my n value as my 4th term. So I'm going to plug in 4 into my equation. So I'm going to have T sub 4 equals 2 times 4 minus 1. So when I multiply that, I get 8 minus 1, and that is equal to 7. So what I'm saying here is that in the 4th figure, in the fourth figure, I have an output of 7 cubes, and that is true. So when we check it, we verify that the equation we got was correct. Now let's try this again in example 2. So in example 2, we see the question of using the explicit formula to find. We want to find the equation that's going to give us the nth term of our sequence. So that's going to be our goal here in the first part of example 2. So let's go ahead and write down our formula, our explicit formula, in order to help us. Okay, so I have the formula down. T sub n equals T sub 1 plus D, and then n minus 1. So the two things that we need if we're given a sequence is going to be the first term, which for us, that is equal to 5. Our first term is 5, and we also need to know what the common difference is. So if we look for our pattern in our sequence, 5 to 6.5 to 8 to 9.5 and then to 11, we are adding 1.5 each time. So our common difference is 1.5. Those are the two things that we need. So we're going to take that information and we're going to plug it into our formula. In our formula, again, we've got T sub n equals T sub 1 is now 5 plus our common difference of 1.5, and then in parentheses is always n minus 1. Okay, so going through the steps in order to simplify. To go through the steps in order to simplify, we're going to have 1.5 being distributed into our parentheses, and that's going to give us 5 plus 1.5n minus 1.5. So our first step of simplifying is to distribute, and then our second step is to combine our like terms, which would be 5 and negative 1.5. So that's going to give us 1.5n plus 3.5. So that's the equation that we were needing. T sub n equals 1.5n plus 3.5. So the biggest reason for knowing what our equation is so we can predict, or we can know the output of any term in this given sequence. So in part B, we're going to find the 20th term. Now that might be most clearly seen by creating a table. So if you want to create a table over here on the side where we have our input values, which are n, the nth term is our input values, and our output values is going to be T sub n. So we have the first 5 terms in our sequence. So our n's are the first term, second term, third term, fourth term, fifth term, so on and so forth. So I'm going to do my little dots to help me out there. So we have our first term as 5, 6.5, 8, 9.5, 11, and then that pattern is going to continue. Now, the hard way of doing this is just to keep going with that same pattern until we reach the 20th term. But with our equation, we don't need to do that because we know now how to input values into a function whenever we know what that input value is supposed to be. In this case, we want to know what the 20th term is. So if I plug that in as my n value, I'm going to calculate this 1.5 times 20 plus 3.5. So 1.5 times 20, that equals 30, and then if we add our 3.5 to that, we are going to find that our 20th term is equal to 33.5. And we did that without having to continue that pattern up until our 20th term. So our answer to part B is 33.5. Now, I want you to try the questions under the You Try section. And then whenever you write your summary, don't forget to answer the essential question. And then if you have any questions over these video notes, make sure that you save those for a class discussion and reflections. Now, I did promise you the answer to my joke. How do you fix a broken jack-o'-lantern? And the answer to that is you have to have a pumpkin patch. All right, that's the end of our video notes. So Watley is out.